Okay, class. Today we're going to continue talking about functions. So far, what we have done with functions is we know that a function takes in one input and gives you back one output. We also have looked at the domain of functions. All right, we know how to write it in interval notation form. And so now our next target is to try and find or learn how to graph functions. So there are two ways we can do that. One way is to do table of values. So you write down as many x input that you want, and then you plug it into the function to give you the corresponding y value, so that you're generating a set of points that you can put on the graph and be able to connect the dots together and graph it. The other way is to use your graphing calculator, or if you have Desmos, you can just punch in the function and it will graph it for you. So what we're going to do is there are some functions that you need to be aware of and know how that graph looks like. And this is how you build your repertoire of what? Of functions. All right. So think about these as you have to know them. All right. So when somebody talks about x squared, the graph of x squared, you already know what that function looks like. If they talk about x cubed, square root of x, absolute value, you have an idea as to what it is, and you're not reaching out for your calculator to go graph it, but you already know what the graph looks like. So I'm going to go through these, and these are what we're going to call the basic block functions. So when I say, well, recall your basic block function, you should be able to remind yourself or remember these simple functions that we know what their graph looks like. All right. So let's look at the first one. So the first one I have here is the function x squared. And so I have a bunch of input, and I'm going to try and find their corresponding y value. So when I say at x equal to -2, I end up with f of -2, which is -2 squared, which is 4. So now you have a point, which is what? -2, 4. And I'm going to do the same thing, -1. I get -1 squared is 1. So I have -1, 1. And then f of 0, got to keep up with the same. So you get 0. So you have 0, 0. And then when it's at 1, you have 1, no, squared. And squared is 1. So you have 1, 1. And then when it's at 2, you're doing f of 2 is 2 squared is 2 is 4. So you have 2, 4. And remember, these are not lines, all right? These are not linear functions. So you know that these are going to be curves. So let's locate the point. I have 2, -2, and 4 is right about here. You get -1 and 1 is about here. You get 0, 0, 1, 1, and 2, and 4. All right, so if I try to sketch this, it looks like I'm going through there. I don't know if that's a good color. Let me change that to that. Let's see. I think that's much better. And then it passes through there. And it goes there. That's f of x is equal to x squared. All right. So there's a couple of things that I want us to do as we're going through this. So we talked about domain and range in the other videos. So let's look at this function over here. Remember that this function can continue forever. So when we talk about domain, we're talking about all the possible x values all the possible x values that this function has. You can clearly see that for every x, it's got a corresponding y value. For every x, it's got a corresponding what? Y value. So we can say that the domain is what? All real numbers. Well, how about the range? The range describes all the possible y values. And for this, what are the possible y values? For every x, it has a corresponding y value. So I know that the range is going to be y belongs to from what? 0 upwards, including 0. So I show that by the square bracket, 0 to what? 0 to infinity. Okay. I want us to also look at something called increasing and decreasing. So when I talk about increasing and decreasing, well, you can clearly see that if you read your graph from left to right, you're coming down this way. And you always read our graph from left to right, all right? Not from right to left. So if you read the graph, if you read the graph from left to right, you can see that it's decreasing, meaning that if you pick an x value and you compare it to the next one, the y values are decreasing. All right. So if I compare whatever this is, if this is x2 and this is x1, you can clearly see that the y value for x2 is bigger, but then x1 is smaller. So that means that the curve is decreasing. So here we say that it's decreasing. Well, let me put that over here. It's decreasing from negative infinity all the way till it hits 0. Okay. And then it's increasing from 0. You can see that for every x, if you compare two x values, you can clearly see that this x, if this is A and this was B, if you compare A and B, their y values is always that B is the y value for B is bigger than the y value for A. So the values of y are getting bigger and bigger as you compare any two of them after 0. So we say that it's increasing from 0 to what? Positive infinity. All right. So those are the things that we're going to look at for each of these functions to see what's going on. Okay. All right. Let's look at the next function. Again, I have some values of x that I'm going to plug into my table of values and sketch it. So if I look at f of negative 2, that gives me negative 2 cubed, which is negative 8. If I have f of negative 1 and I plug that in, I get negative 1 cubed, which is negative 1. F of 0 is 0 cubed, I get 0. And then f of 1 is 1 cubed, which is 1. And f of 2 is 2 cubed, which is 8. So I'm looking at the point negative 2, negative 8. I'm looking at negative 1 and negative 1. Looking at 0, 0. Looking at 1, 1. Looking at 2, 8. So when I locate this, I have my 0, 0. I have my negative 1 and 1. And then I have my 2, negative 2 and 8. And then if I come over here, I have 1 and 1 and 2 and 8. So when I graph this function, I'm seeing okay. So again, this graph continues forever. So when I talk about the domain, let's look at the domain. So the domain is all the values of x. You can clearly see that for every x, you can find a y. So it looks like the domain is x belongs to all the reals. And then if you look at the corresponding y value, since this is going forever, you can clearly see that it's all the y values. All right, because for every x, you have an output. Every x, you have an output. Every x, you have an output. So the range is also all reals. Now, is this function increasing or decreasing? So if it's increasing, I expect the y values to be getting bigger and bigger. If I compare any two y values, I should see that the previous one is bigger than the next one. All right, so if I look at these two, I have -2, the output is -8, and -1, the output is -1. If I read the graph from left to right, it looks like the graph is increasing. You can clearly see the graph is increasing from left to right, and it seems like it's going forever, so it's increasing -infinity to +infinity. Is it ever decreasing? Do you see the y values decreasing on this curve? There is no way. All right, so remember, you always say there is none over there. All right, let's look at the next one. So the next one is a square root, and the square root, one of the things that we know is that it cannot have a negative number, so I can't even look at the negative side of the real number line, but I can start with 0. So what is the square root of 0? You end up with what? 0. Square root of 1 is 1. Square root of 2 is square root of 2. Square root of 3 is square root of 3. And square root of 4 is 2. All right. So clearly, you can see that I have some really interesting points that I can look at. I have 0, 0. I have 0, 1. I have 2, root 2. 3, root 3. And 4, 2. So I can certainly plot the really nice ones. So let's locate those. Okay, so I have 0, 0. I got 1, 1. And then I got 4 and 2. So the other ones, you can clearly see that they are between, the square root of 2 and square root of 3 are between 1 and 2. Can't really locate it over unless I use my calculator. But I know that it's in between 1 and 2, so the graph will look like something like this and continue in that manner. So here, what's my domain? My domain, I'm strictly starting at 0, so I'm going 0 to +infinity. You can clearly see for every x, you can see that you can match it to the graph, and it's also got a corresponding y value. So when we talk about the range seems to start, the y values of this graph is always from 0 to what? 0 to infinity. The question is this also increasing? So increasing or decreasing? If it's increasing, that means that the y values are getting bigger as you check each x value. So you can clearly see that for each x value, the y values are getting bigger and bigger and bigger and bigger. Reading from left to right, the curve seems to be increasing and increasing. So you have that this increases from 0 to what? 0 to infinity. There is none for decreasing. We don't see anywhere on this graph that decreases. Okay. Now let's look at the next one. The next one is the absolute value. And hopefully this is not new, all right? You've seen this before. So absolute value says that you take, whatever you plug in, you're going to look at it in terms of 0 to all the positive numbers. So you're looking at the -3 would turn itself to what? Turn itself to 3. So you have -3, 3. -2, absolute value of -2 will become +2. So you get -2 and 2. -1, absolute value will become +1. So that becomes -1 and 1. 0 becomes 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. So I have 0, 0, 1, 1, 2, 2, and 3, 3. All right, so if we locate this, we have these points. One, 1, 2, 2, and 3, 3, and -1, 1, -2, 2, and -3, 3. So it looks like these are straight lines. The other one is there. So we can see that if you have an absolute value graph, it looks like you have a V shape pivoted at the origin. All right, so again, let's look at the domain. So the domain, you can clearly see that forever, and again, this function is going forever. It doesn't stop. So it looks like it takes any x value that you can give it. It will spit back out to you a y value. So the domain, all the x values that this function can have is x belongs to -infinity to +infinity. How about the range? The range looks like all the possible y values are just at the top over here, the positive y axis. So y belongs to, strictly starting from 0 to a +infinity. And again, if you look at it, is this function increasing or decreasing? We can clearly see, if you're reading from right to left, you can see that the function is decreasing all the way till you get here, and then it starts to increase from there going. So I can clearly see that it's increasing from -infinity all the way to 0. And then, oh, sorry, that's for the decreasing portion. Sorry. It's increasing from 0 to infinity and decreasing from -infinity all the way to 0. Okay, now let's look at the last one. So the last one is an interesting function, and hopefully you enjoy how this works. So what it says is that this is called a flowing function. And what it does is that it takes in an x value, and the way you evaluate it is that you're looking for the greatest integer. So remember, integers are -1, -2, 0, 1, 2. So looking at positive and negative whole numbers. Those are what integers are. So I'm looking at the greatest integer that is less than or equal to x. All right. So let's do the positive side first so that you can get an understanding of what's going on. So it's saying that when I have the flowing function 0, what is it greatest integer less than or equal to 0. That's just 0. When I do the same thing over there, when I pick 0.5, 0.5 is a decimal. We're looking at the integer that is the greatest integer that is less than or equal. So when you look at an integer that is less than or equal to 0.5, that integer is what? Is still 0. Because 0 is less than, it's an integer that is less than 0.5. When I pick 0.9, I'm looking at that number and I'm going, what is that greatest integer that is less than 0.9? Again, that is still what? That is still 0. And then we have 1. The greatest integer that is less than or equal to 1 is 1 itself. Now, when I pick 1.2, what is that integer that is less than or equal to 1.2? It has to be 1. I'm looking at 1.5. I'm looking at the integer that is less than or equal to 1.5. It has to still be what? 1. And then once I hit 2, we get 2. So I hope you've seen the pattern. So that means that if I look at anything between on the number line, if I'm at 1, anything between 0 and 1, if I try to evaluate it, it's going to give me what? It's going to give me the greatest integer that is less than any number between 0 and 1 is always going to be 1. If I go to between 1 and 2, any integer that is, if I try to evaluate it again, you can see that any number between 1 and 2, the greatest integer that is less than any of those numbers is always going to be what? Is always going to be 1. All right. So this is what you're trying to do. If you fill out this, you can clearly see that if I pick 2.3, I'm going to get 2. If I get 2.6, I get 2. And then if I get 3, I get 3. Now let's look at what's happening with the negative ones, because the negative ones are a little bit tricky. If I go to negative 0.2, can you think of an integer that is less than negative 0.2? So remember that when you're on the negative side, the bigger the number is, the less negative they are, all right? Or the more negative they are, rather. So when I look at negative 2, an integer that is less than negative 0.2 has to be negative 1. If I look at negative 0.5, because negative 1 is less than what? Is less than negative 0.2. If I pick negative 0.5, the greatest integer that is less than or equal to negative 0.5 is negative 1. If I pick negative 1, then I'm at what? I'm at negative 1. If I go to negative 1.5, the integer that is less than or equal to negative 1.5 has to be negative 2. We get negative 1.9, it's going to be negative 2. Negative 2 is 2. Okay. And then we have negative 2.7 is what? Negative 3. Negative 2.9 is negative -3. And then we have -3 S3. Okay, so let's try and plot this together. It's a whole lot of points, but let's see what's happened. Let's do the positive side. So the positive starts right over here. And then as I go through all the positive points, so if I go through these, it looks like 0.5 is still here and 0.9 is right there. But if you look at every single point between 0 and 0.9, we are all on this line here until it reaches 1. And when it reaches 1, it looks like the function now is at 1, 1. So that means that what happened over here, we're going to put an open circle right there. All right. And then continue again. So if I look at the 1, 1, where the y values are 1, it looks like it's between 1 and 2. So between 1 and 2, it's a horizontal line until I get to 2, and then the thing jumps again to 2. So that means I need to put an open circle over here because the function jumped. All right. And then at 2, if I look at all the y values that have 2, it starts over here and it's horizontal until it gets close to 3, and then at 3 it jumps. So I put an open circle over there. And so that pattern continues. That pattern continues forever like that, in that fashion. Now let's look at the negative. So the negative at 0, I already have this. So it's going to continue this way and then do this. All right. And then jump again from there and continue in this fashion. And then do the same thing over here. Jump again and go in that fashion. So we call this, the way this looks like, this is what we call the greatest integer function, or we call this the stepping function. All right, so some people call this guy here the stepping function. Now, what is the domain? Let's look at it carefully. So you start off with, let's look at just a little that we have. We start off with -3, and then you continue so for every x value, you have the same thing. And then once it hits 2, it jumps to this. And it continues in that manner. Every x has a corresponding y value until it hits the next integer, and then it jumps. But it's accounting for every possible x value. So the domain is what is all real. The range is all the y values. And you can clearly see that when I'm at 3, I'm right here. But in between, there are no points. There are no points between -2 and -3, and -2 and -3. I don't have any values over here. I don't have any portion of the graph between -2 and -3. So it looks like the y values are just these guys. They're just these guys. All the integers that we have on this number line. So this is y belongs to the set of integers, and that's the notation. Z is for integers. So we have as the set of integers. Or you can clearly see that y belongs to -3. So you're starting from infinity, -3, -2, -1, 0, 1, going, the set of integers. All right, now the question is this increasing or decreasing? When you read from left to right, it looks like I do, it's horizontal and it jumps 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 and it jumps. So for every y value, you can see that there is an increase in this. So it's hard, I mean, it's kind of tough to see it, but you can see that for every y value, you are what? You are increasing. So you're increasing. Or for every x value, you can see that the y value starts off with -3, -2, -1, like that. So it's increasing from -infinity to +infinity. So you start off with 3, and then it goes to 4, goes to 5. So it's an increasing function. All right. Hopefully, this is helpful. So these functions that we've looked at, the parabola, x squared, x cubed, you should familiarize yourself with them so that you know what they all look like. All right. So that when you see it, you don't go, okay, what does this function look like? How do I graph this function? Okay. All right. So I've spent a lot of time trying to explain how we do this. We are graphing either by table of values or using a calculator. And that's how you do table of values. You got to get the corresponding x and y values and locate it on the graph and plot them. Okay. Thank you.